two things you need to remember for all of those questions. Initial velocity, and somehow they have a collision. You remember this equation, right?
We use it as M1 U1 plus M2 U2 in the beginning.
Oh, it's fine. It's the same thing.
Okay.
So it's the initial velocity and the final velocity, right? That's a conservation of the momentum. And then the second thing is, if there is elastic, let me change. For elastic collision, the kinetic energy, the initial one, the final one, should be equal. The energy is also equal. So
that's for elastic or inelastic?
Elastic.
Okay.
Is equal. Okay. So the first question is 1.2 kilogram object moving with a speed. It's 1.2 kilogram moving with a speed 80 meters per second to a wall. Okay. And then to the wall, and then come back with a speed of 6 meters per second. Okay, and then in the opposite direction, if the time is intact with the wall is 2 milliseconds, what's the magnitude of the average force on the object by the wall? There are different ways to do it. My way to do it is, so we can see the delta velocity, right? Is from 8 to -6. The change is 14, velocity change. And the time we know is 2 milliseconds, which is 2 times 10 to the -3, right? Second. And then we can get the acceleration will be 7 times this value over the sorry, times meter per second squared. So you understand here?
So now you're going to do the force is equal to MA?
Yeah, so right? A equal to F over M, and then asking you the force will be MA times 1.2, which will be 8.4 kilonewton. But the question is the magnitude of the average force will be 8.4. That's according to what we have learned. We can do it this way. But from the new knowledge, there is a different way to do it. Is the change of the momentum will be m times -6 minus m times 8, right? That will be equal to Ft. You understand here?
So that's the impulse, right?
That's the impulse. Exactly. So that way it's easier, the calculation. But if you understand, that way it's easier. That would be 10 to 1.2 equal to, if we put t here, t is seconds. So calculate, that would be 7 times 1.2 times 10 to the 3 Newton, which will be 8.4 kilonewton. There are two different ways, but they're the same thing. And the second question, again, we need to calculate the area. 1, 2, 3, 4, 8. So that's the force, and that's the time. The only force acting on a 2 kilogram object moving along x-axis is this. The velocity is -2 meters per second at time equal to 0. And the question is, what is time at 4 seconds? So Ft say from 0